Sir, you are recording the meeting?
Yes.
Okay, sir. Okay. All right. So, like sir has informed in the group that today's topic will be motion and laws of motion. Today, we will simply understand the basics of. Of course, it is not new to you. Of course, it is not something that you have never learned before or never understood before. But what we will do today is we will simply revise the basics of motion. That means the aspects, the physical quantities associated with motion. So, is there anyone who can simply list the quantities, physical quantities associated with the concept of motion? What do you think would be the parts, the aspects that we will understand today? Anyone? Is there anyone who understood the question and wants to answer?
I think we will, the components are force, mass, like that. That's what you are meaning, madam?
Yes, yes, yes.
Right.
But we
Try
will
to
go
know
with
it.
the
We
basic.
know, yeah.
Yes, someone was saying?
Ma'am, difference between distance and what is distance and displacement,
Correct,
acceleration, velocity.
correct. So what we are going to understand today is the very basics of motion. That is, first of all, what motion is. Second, the difference between distance and displacement. How in practical life we understand distance and displacement separately. Then there is the uniform and non-uniform motion. Again, we will understand the application of those concepts in practical life. Then there is speed versus velocity. Where to use speed, where to use velocity, which physical quantity is more practical to use. See, you understand everything by far through NCERT textbooks or any other reference books of yours. The theory of each and every concept. But what we need to understand under the foundation course is how you apply those things in your practical life. Because sometimes what happens is while you study something, you realize, I don't understand this practically. I don't understand this how distance is directionless and how displacement is with direction. We don't understand that in practical life. So what we will do is we will understand the theory. We are aware of the theory very well through our studies, but to go for something that is applicable in practical life is what we are here for. So we will understand the concepts of distance, displacement, the difference between them. Then we will understand speed and velocity, the difference between the two quantities. Then acceleration and uniformly accelerated motion. There is a in practical life there is a separate situation for each of these aspects. We will understand them in detail through a presentation is very precise. You will not understand each and every detail through the presentation. So if you are thinking that you will not listen to me and you will just refer the presentation, you will not understand what I'm trying to say. So presentation is simply for your graphical approach. You will simply look at the words and the figures there, but you have to listen to what I'm saying, because understanding the practical part is what will come out from me and not from the presentation. Is that clear? So let's begin with the presentation now. I'll be sharing my screen. All right. So today is all about the basics. First of all, let me just ask, am I audible?
Yes, ma'am.
Okay, and the screen is visible, right?
Yes, ma'am.
Okay. So we will understand what is motion and the laws of motion will be taken up in the upcoming sessions. Today, what we are going to understand is how to describe motion, distance and displacement, uniform and non-uniform motion, speed and velocity, and acceleration. Describing motion. What do you understand by motion? Anyone can answer that. Very basic question this is. What do you understand by motion? When I say the word motion, what comes to your mind?
Change in position, ma'am.
Change in position. Okay. So that is simply when an object moves from one to another position, we say it is in motion. Okay. Like we know, the origin, the beginning point from where the object begins its motion is called its origin. And the most simplest form of motion is motion along a straight line. Because obviously there are other forms of motion. We understand the motion by simplest form as the motion in straight line. What are the other forms? Who can say? What are the other ways in which a object can move?
Revolutionary motion, ma'am.
Yes,
Rotational motion.
I can't hear you.
Oscillatory motion, ma'am.
Oscillatory motion. What do you mean by that?
To and fro motion, ma'am.
Okay. Then what is the other kind?
Circular motion, ma'am.
Circular motion. There are multiple ways in which an object can move around in a given space, but the simplest form is of linear motion, correct? Motion along a straight line is called linear motion. So if you can see through this figure, if you understand this figure, see the car begins from point O on a straight line, moves to A, moves to B, moves to C, and then from C again comes back to A. So what do you think is the distance covered here? What will be the total distance covered here by the car? Yes, anyone?
OC, ma'am.
O to C?
Yes, ma'am.
But the car is coming back to A also now.
OC to CO, ma'am.
OC to CA. It is stopping at A.
Yeah, yes, ma'am.
From O to A, O to A to B, B to C, and then C to A. So this is the total distance covered by the car. Then what is displacement here?
Ma'am, OA, ma'am.
OA? Because originally it is from O to A. But in the upcoming slide, I have given that the displacement will be 0. When will the displacement be 0?
When it again comes back to home, ma'am.
Correct. So to understand that, I have given in this next slide that if the object returns to its original position, that is on O, then the object will have displacement 0. So what we understand here is that the distance traveled is the total length of the path covered. Doesn't matter where it is going. It can go from O to A to C, then C to B, then B to C again, and then C to A, and then A to O. In such cases, every part, every distance counts as the total distance covered by the car. The entire addition, mathematical addition, simple. We are not talking about the position, we are simply talking about the numerical distance it travels. So, what is distance? Distance is the total length of the path covered, where only magnitude of the distance is needed. The magnitude of the length is needed. What do you understand by magnitude? It is the numerical value. Okay. So from the example, distance is OA plus AB plus BC plus CA. What is displacement then? It is the shortest distance traveled by the object. This is the perfect definition of displacement. Spelling error. Okay. The perfect definition of displacement is when you consider the shortest distance. See, the car has gone from O to A to B to C and then again to A. But what is the shortest distance covered by the car is O to A. Simply, it does not consider the time period or it does not consider the entire path length. It only considers the change in position. Initially, it was at O, finally, it has come to A. When does the displacement become zero? That I have given here as displacement. I think it should be O to O, that is zero as the object returns to its original position. When? In this case, it is OA. In this example, it is O to A. Displacement is OA. But when will it be zero? It will be zero when the car comes back from A to O again. Getting the point?
Yes, ma'am.
Yes, ma'am.
Okay, so this is distance versus displacement. All right, what do you think is the SI unit of distance and displacement?
Ma'am, for both meter, ma'am.
Meter. Meters is the SI unit for distance, that is distance and displacement. Other sets of units are obviously centimeters, kilometers, but the SI unit, that is the standard unit, is distance meters. Okay. Now my question is, what is uniform motion? What is uniform and non-uniform motion?
Ma'am, when an object covers equal distance in equal intervals of time, it is called as uniform motion, ma'am.
Correct. And non-uniform, unequal distances and equal intervals of time. So here I have not given any examples. Can anyone give me certain examples?
A car moving in the same speed, ma'am, in a highway.
Same speed. What do you mean by that? Give me an example through distance and time.
Ma'am, a car moving at 5 km/h speed, ma'am.
That means it covers 5 kilometers in 1 hour. It covers 10 kilometers in 2 hours, 15 kilometers in 3 hours. If that is how it goes, if that is how it continues to work, then it becomes uniform motion. And then non-uniform motion is obviously its distance coverage changes with time. Because initially it travels, let's say 10 kilometers in the first 1 hour. Then the speed increases and it can cover more than 40 kilometers in the next hour. Then it means
Yes.
that there is a coverage of unequal distances in equal time intervals. Why we say equal time intervals is because we consider unit time per hour. We consider that per hour in what distance is being covered in 1 hour. So that is the example. Now I have given this question, is uniform motion possible in day-to-day life? Obviously the answer is no, but why?
Ma'am, because each day our routine will be changing, ma'am.
What will be changing?
Our daily routine, ma'am.
Routine. Okay, I'm not saying that. I'm saying about let's say like you gave an example, a car moving on a highway. Why does it also not have uniform motion?
Due to some traffic, ma'am.
There are multiple reasons. Okay, so you cannot directly start your journey from highway. You begin from your home, you enter a highway, and then you again enter another city while traveling. So in the city, from home towards the highway, there will be more traffic. The roads will be non-uniform, non-linear. Then there you have to control your speed. You have to control the distance that you cover in unit time. That is the reason why there is always, in most 99% of cases, there is non-uniform motion in day-to-day life and not the uniform motion. Uniform motion is almost impossible to regulate in daily life. It is not possible to have uniform motion because of certain aspects. One is the structure of road, another is the traffic, third is the driver's abilities. What other things can you think of for not having uniform motion in daily life?
Some problems in car, ma'am.
the condition of car, correct? If the car is old and it requires services, it won't go with the required speed. So basically, some external aspects play a role in deciding that non-uniform motion will be there in practical life and not uniform motion. Correct? Okay. So the next part is speed and velocity. Now I want to understand the difference between speed and velocity. First of all, what is speed? What is velocity? Can anyone answer that?
Ma'am, speed is the total distance covered by time taken, ma'am.
When you say total distance covered by time taken, it is a formula to find speed. I understood that by theory. I'm not saying that. I want to see, I want to understand by practical aspect. What do you mean by speed? When you say the speed of the car is 40 kilometer per hour, what does it mean?
Ma'am, the total distance covered, ma'am.
Total distance covered. When I say this statement that the car is traveling at a distance of 40 kilometer per hour, it is currently traveling. What does it mean? It is not the total distance. The journey has not yet ended. So what do you mean by that?
What is the rate at which an object is moving, ma'am?
That means that the car covers 40 kilometers of distance in 1 hour, in 60 minutes. That is how you express speed in practical terms. That when a car is traveling, then it covers 40 kilometers in a given hour, in 1 hour. That is what we understand by speed. So what you see in your car or bike or odometers, do you know now that the vehicles have 2 meters, 2 display meters? What are those 2 meters?
Speedometer and odometer, ma'am.
So what does odometer display?
Total
The
distance
distance
covered by the
traveled by
vehicle,
the
ma'am.
car, ma'am.
Correct. Displays the total distance covered, and the speedometer tells you the current speed of the vehicle. So the total distance covered will change with the journey you are taking up, and the speed will change momentarily. It will change at every moment because of the variation in the values of your speed. Okay. So now when we understand speed and velocity, what is speed? Speed is distance traveled in unit time. Very basic definition. That the total distance traveled in unit time or in a given period of time, we call it speed. Of course, it is again a directionless unit. It requires only and only magnitude and not the direction. Then what is velocity? What is the basic difference between speed and velocity?
Ma'am, speed does not have direction, but velocity has direction, ma'am.
So how can you describe
Speed is a
velocity?
scalar quantity and velocity is vector quantity, ma'am.
I know the theoretical terms. That is why I have not involved any theory here. I have not written any theoretical terms. I know you all are aware of the theoretical terms. What I'm asking is the practical difference between speed and velocity. When do you use velocity? Okay, tell me something. The speedometer of your car displays the speed or velocity.
Speed, ma'am.
And why not velocity?
Because no direction is shown in that speedometer, ma'am.
Of course, because there is no direction you can feed in your vehicles. Okay. So basically, velocity is used not through a journey. Velocity is used when you want to understand the object of a particular motion. So velocity is basically speed with direction, that is displacement in unit time. This is a very basic definition of velocity, the total displacement in unit time, which means When, see, in the previous example, in this example, if I say that from O to coming back to A, okay, O to B, O to A to B, B to C, C to A. The total distance traveled by the car is, let's say, 50 kilometers, and it took about 3 hours of time. So, what is the speed here?
5 kilometers.
The numbers I said, the total distance from O to A is, let's say, 10, from A to B is 15, from B to C is 20. I'm just randomly saying the numbers, please consider that. And C to A again 20 plus 15, that is 35 kilometers. So total distance traveled is how much? 10 plus 15 plus 20 plus
80,
again
ma'am.
35.
80,
How much
ma'am.
is it? 80. And I'm saying, let's say it took about 4 hours to cover that distance for the car. So what will be the speed?
20 kilometers per hour, ma'am.
20 kilometer per hour. But now, if I ask you the velocity, what will be the velocity of the car here?
From O to A, ma'am.
O to A upon total time taken for reaching the car from O to A during the entire journey. Not the only the first time, but the entire journey. So it has taken 4 hours for the car to reach from O to A. Alright, so and the distance only being covered 10 kilometers. So 10 upon 4 is your velocity here. And when you write the velocity, you write O to A. Okay, this is very basic understanding of velocity. And when you want to find the average velocity of the entire journey, you begin with initial velocity. What will be the initial velocity of the car in the beginning? Here it will be 0 because it is starting at a particular point, that is, it's steady. And with time, we will consider how much time it has taken for from O to A, then A to B, then B to C, and then C to A. And individually, we will understand the final velocity, and then we can calculate the average velocity. We will understand the numericals also. We will understand this. This was just a basic example. Don't try to, don't get confused with the numerical. We will understand the numerical practically. So, changes, what changes with magnitude is velocity changes with change in magnitude or in direction of motion. Even if the speed remains steady for a particular journey. But if it is moving, if it is going straight and then suddenly it takes a left or right turn, that means it has a change in velocity. This does not apply in case of speed. So when you want to find the average velocity of an object in the entire journey, it is initial velocity plus final velocity upon 2. That is the average of the two velocities. Are we clear with this?
Yes, ma'am.
The SI unit of velocity and speed is both for both is meter per second. Other units are centimeter per second and kilometer per hour. In practical life, we mostly use kilometer per hour. Now we simply understand acceleration and uniformly accelerated motion. To understand acceleration, you should have a very specific idea of what velocity is. Now, what do you mean by acceleration? Who knows? Who can, in practical terms, explain what acceleration is?
Ma'am, the change in velocity of an object is called as acceleration, ma'am.
I said in practical terms, this is a definition.
Madam, it is like this in a traffic when we were waiting. That time our velocity is 0, and immediately when the green signal comes, we pick up speed. Some of the bikes are they pick up speed very fast.
Correct.
So that we can call those bikes are acceleration is very high. Like for example, my scooter, it is an old scooter. It picks up very slow. The man is also old. The scooter is also old. So it becomes less velocity. So acceleration is small. This is how I understand.
Absolutely, absolutely. This is what I want from the students, that they understand this in a practical way. That basically, when you are at a signal, if the signal is red, you are waiting for it to turn green, and when suddenly it turns green, what happens is a scooter like that of Sir, it will take time to begin its journey, to begin its motion, while some biker will suddenly press the acceleration, either press or roll the acceleration of his bike, and he will move before Sir even realizes that I have to begin the scooter. Okay, so that is acceleration. That it's not velocity. Currently it is not velocity, because what velocity is, the object will move constantly. Velocity is, it will move steadily. If you are in a usually, practically all objects are in accelerated motions. When we talk about vehicles, automobiles, when we talk about two wheelers or four wheelers, they are always in acceleration, because when you steady the speed, you are still wanting to keep it accelerated. If you are I'll just give you an example, because most of you might not have ridden the two wheelers. I'll give you an example of cycles. Is it possible for you to pedal your cycle one time and it will keep moving? Is it possible for that?
No, ma'am.
No, you need to constantly move your legs to keep it in motion. Correct? Then what you are providing to your cycle is the acceleration. Because if your vehicle or your cycle or your car is constantly moving, then it has gained certain velocity, because there is a motion of the object. But to keep it moving, you need to accelerate it, because with time it will slow down. Now my question is, why does your vehicle slow down even if there is no force acting on it? This is a very, very interesting question, and the answer is very simple. If I tell you the answer, you will be surprised that, okay, this was the easiest aspect to understand. The question
No
is,
force is given to the to pedal,
no,
ma'am.
no, force acts in what way? You are applying the force and the motion starts. So to stop the motion, there must be a force, right? Which force stops your motion?
Frictional force, ma'am.
Frictional force, exactly. Exactly the word I'm looking for. So to cut the friction and to keep your object moving, you need acceleration. So theoretically, acceleration is rate of change in velocity, that is in a given unit time. That is, Vf is final velocity minus Vi is initial velocity upon time taken. This is theory. This is basic theory. Change in velocity. That means the change in speed. Now the change can be increase also, decrease also. When there is a decrease in velocity, we call it retardation. And we take the value of acceleration as a negative value. We will understand that through numericals, but understand this, when there is a negative acceleration, the term we use for that is retardation. Then what is uniformly accelerated motion? What do you understand by uniformly accelerated motion?
When the velocity changes at equally at equal intervals of time, ma'am.
What does that mean? It means that the velocity is that the object is moving at steady speed.
No, ma'am. It should be increasing or decreasing, ma'am.
Correct. If it increases or decreases with time, and that is uniform time, that means the increase or decrease is uniform, then we say that it is a uniformly accelerated motion. That the speed or the velocity of the object is constantly either increasing or decreasing. Now I have given a simple hint here to understand this. the concept of free fall. What do you mean by a free fall and how it is called uniformly accelerated motion?
Now, free fall means acceleration due to gravity, ma'am.
So how is it uniformly accelerated? Uniform, why uniform? Why uniformly accelerated?
Ma'am, because the acceleration of an object in free fall increases in by equal amounts, ma'am.
Because it is free fall, there is no other external force acting on it. When there will be non-uniform acceleration, when someone is providing the acceleration externally. But when we talk about a free fall, there is no external force applied except the gravitational force. That is why the acceleration of the gravity, that is the gravitational acceleration, which we denote by small g, the value is obviously constant 9.8. We will understand that in gravitation. But when there is a free fall, there is no external aspect acting on the object. That is why we call it free fall. Correct? But in other cases, like in the case of accelerating car or bike or a bicycle or any other object, there is always a factor that is working externally on it. It is your leg that is working on the acceleration. It is your hand that is working on the acceleration. But in case of free fall, it is only the constant gravitational acceleration acting on it. That is why it is uniformly accelerated motion and not non-uniformly. Is that clear?
Yes, ma'am.
That is why in the scooter or in the bike they call it as accelerator, because you are increasing.
Yes, exactly.
That name has come from that acceleration.
The correct. The unit of the SI unit of acceleration is meter per second square. Why square? Because it is change in velocity, that is meter per second, upon second, that is meter per second square. Is that clear?
Yes, ma'am.
Okay. So these are the basics of your motion, the physical quantities associated with motion. What next we are going to understand is how you represent the motion through graphs. When you talk about distance time graph, when you talk about velocity time graph, we will understand how they are represented through graphical methods, how they form a line or a parabola or a non-uniform structural graph on the graph paper. So next session will be very important because it will be about the graphical representation of motion of various graphs like distance versus time, velocity versus time graph. Clear?
Yes, ma'am.
Okay. Any questions?
No.
Madam, I have one question for the students.
Yes, sir.
In a free fall, what will be the initial velocity? This is for students. What will be the initial velocity?
0, sir.
Zero. Correct. When it falls from the top towards the earth, towards the ground, then the initial velocity will be 0. Correct. Very good. So these are some basics we need to know. Any queries from the student side? You can ask any queries. What will be the gravity in moon? Any idea? You must have studied.
No
Sir, 1 by
gravity,
6.
sir.
Yes, somebody said something.
Sir, 1 by 6 of Earth, sir.
Is it correct? Anyway, you check and let me know in the group. Okay. Somebody,
Yes, sir.
you check
Yes, sir.
yourself and then let me know.
Yes, sir.
Thank you, madam. I mean,
Okay, if it is 1/6, why so? If you are saying it is 1/6 of the Earth's gravitation, then why 1/6? Why specifically 1/6? And why the value is constant for that? Also, I want to know why the value of gravitational acceleration is also constant. If you can find out, please do that. We will discuss that in the next class or on the group.
Now I started getting one doubt whether it is really constant. It is 9.8.
We will understand that, sir. The students will explain us.
Yeah, please. Students, now I got a basic doubt, which I studied when I was like you, 9.8 meter per second square. Now I started doubting it. So check, I mean, you may get such doubts also. And then let us see whether it is constant or not. Okay.
Is it constant for all the parts of the Earth?
No,
If not,
ma'am.
why? Why? Where is it more? Where is it less?
Ma'am, in the center of Earth it is more, ma'am, and at the poles it is less, ma'am.
Why so? You all know the theories, you all know the statements given in the textbook, but you don't have the answer to why. Why so? You said 1/6. It was very quick for you to answer that. But when sir asked why 1/6 or are you sure about it, you could not answer. So what I mean is, please understand the whys behind every statement you read or learn. You are saying it is more.
Sorry. Carry on, madam.
You are saying it is less on the poles and more on the center. Then you should know why.
Even that is not
That-
correct, madam. I think it is 0 in the center, if I remember correct.
Yes, sir. Yes, sir. That is what I am asking her to go through.
Somebody find out why. I mean, if you reason out, you will not make such mistakes.
The reasons, you should always have the reasons to your answers. When you are answering a certain question, you should always question yourself first why. Yeah, because be ready with this question. After you answer certain things, we will ask you why, and you have to have the answer to that why.
Yeah,
All right.
the curiosity, you apply your curiosity. Children, you do that because you're all still young. No, that curiosity, I think you should apply for forever, throughout your life. That's very important.
Correct. All right. So this is something interesting that sir has taken up. Why the velocity or the gravitational acceleration of the Earth is not constant, or is it constant really? And if it is not, where it is more, where it is less? Why is it 0 at the center? Go and research and
All of you, please
come to us
research
with
and
the
put it
answer.
in the group. I request whatever group you are in, you put it in the group. There are students from 3 different groups, but you put it in those groups. I will share it to other groups
Hmm.
also. Okay. Thank you, madam,
Okay.
for
Okay.
your time. Thank you.
Okay.
Okay. Thank you, sir.
Any doubts? Any Sachin Patel? You will have some doubt now.
Yes, sir. No.
No doubt. Today, no doubt, huh? Okay, very good. Very good. Okay. Okay, thank you,
All
madam.
right.
Yeah.
Okay. Bye bye, sir.
Bye bye.